very much, Eric, for the introduction, and thank you very much for the invitation, and I'm very pleased to be here to share with you some of my thoughts on the loneliness of photography, or the presumed loneliness of it. Can I use this to change up, or?
Yeah, so if you press.
Okay, excellent. Photography has been celebrated as heralding a new epoch. At the heart of this celebration is the feeling that in photography, one encounters something profoundly different from all other modes of representation. This feeling constitutes unabated up to our time, or continues unabated up to our own time. Take, for instance, Jonathan Crary claim that the invention of photography constituted, quote, a vast systematic rupture, an element of a new and homogeneous terrain, end quote. Crary has coined this the photographic effect, or the photography effect. This rupture essentially grounds the belief that photography marks a fundamental break with older, more traditional media like painting or drawing. Photography seems to stand alone. Placing photography on an island of its own, from where it might be compared to other media, but at a distance, has been a means of securing its objectivity and its role as evidence in science. As one historian of science dealing with photography has put it, quote, diagrams could help to inform, maps to chart, drawings and paintings to recognize. But until photography appeared with its promise of a foolproof objectivity, images could only be illustrative, for they could represent, but they could not be used in their own right as evidence. Photography produced a paradigm shift. The sharp dividing lines gleaned in this statement define each medium's own rightful place, only to highlight photography's distinct status in relation to objectivity, evidence, and science. And when comparisons between photography and other media have been made, they typically perpetuate hard and fast distinctions like objective, subjective, mechanical, manual, concrete, abstract. Distinctions that in turn reinforce photography's position alone. The photography effect is so prevalent that we find it operating in the works of authors who have otherwise offered sophisticated accounts of scientific representation. In a classic paper, Science in the Age of Mechanical Reproduction, Michael Lynch wants to preserve photography's distance, or as he calls it, moral segregation from other media like drawing, where the very intrusion of the manual into the mechanical is considered degenerate. And it is something like the photography effect that operates as a foundation source of discontinuities in the influential account of objectivity in Daston and Galison. But there's another way to approach photography, at least with respect to the sciences. And that is as an element within an extended research process, as something implicated in the production of knowledge. Not as something merely to be looked at, but to be handled, marked, worked with, and treated at the scientist's bench. When reinserted into distinct observational and experimental practices of a science, we begin to see something else about photography. We begin to see how very much fused and entangled philosophy is and was with a whole host of other media. This evening, I want to mix things up. By using a series of cases from the history of astronomy, I want to show how scientists fearlessly merged, blended, and fused media. I want to showcase photography's intermediality and its hybridity. And I will argue that photography is not alone. To start, let us turn to 1844, 5 years after the Paris announcement of the invention of photography, when Robert Hunt, the author of Researches on Light, reported that Italian astronomers had taken the first daguerreotype impressions of the nebula in Orion. Using a, quote, secret method of receiving photographic images on a lithographic stone, end quote, the image referred to was this, by Signor Rondoni. For John Herschel, who had recently returned to England from the Cape of Good Hope, and with this, his own elaborate drawing of the same nebula, Hunt's declaration must have been startling. When Herschel finally published the results of the Cape observations in 1847, he wrote therein, were Hunt's claim true, then, quote, the high authority which a self-impressed picture would claim must necessarily lead to the absolute rejection of my own figures, end quote. Herschel, however, was suspicious, and quickly ascertained that Hunt was mistaken. Rondoni, Herschel explained, had not photographed a nebula, but had simply transferred a drawing of a nebula to the lithographer's stone by means of a photographic process, perhaps a kind of photogravure. Indeed, the first photograph of a nebula was not taken until the fall of 1880, over 40 years after the Paris announcement. That said, what is striking about this early incident is Herschel's response. Photography would necessarily lead to the absolute rejection of any handmade drawing. However, only a few years later, Herschel offered a more restrained view of things. In a letter about the aims of the newly conceived Southern Telescope, this was a major Southern hemispherical project to actually put up a large telescope in Australia. In a letter about the aims of this newly conceived telescope, Herschel advised that when it came to the nebulae, photography could only be effectively used to, quote, impress on paper a skeleton picture of the images of the stars only, which might accompany or be disseminated over a given nebula to be delineated by hand. Herschel was endorsing a limited role for photography in relation to handmade drawings. In point of fact, Herschel's suggestion reflected his own sophisticated procedure of drawing nebulae employed previously at the Cape of Good Hope, a procedure that he employed before the invention of photography was even known to him. This was a cameraless procedure that relied on measurements made with the telescope to pinpoint the exact relative positions of a few fundamental stars. These stars, once plotted onto paper by hand, become the foundation for the triangulation of all the other information to be entered in by hand and eye. But what Herschel was suggesting in 1853, so much after this practice here, was to take photographs of the major stars in or around a nebula instead, so that they could act as the basis for the entry of nebulous material by hand. In other words, Herschel was suggesting ways in which photography might come to aid the act of drawing. Just to explain this a little bit, there's a few fundamental stars here. Just look at the really dark ones. These were actually determined using the hand-eye method, using a smaller telescope. And once he gets the exact positions of a few of these stars, at maximum 3, usually 2, he would then plot them into a grid and then begin to triangulate all the other stars that he could then plot in by estimation and not directly from the telescope. So instead of doing this by hand, he was suggesting that photography play that role, that photography be used to capture those fundamental stars and then enter the nebula and the other stars in by hand. That was the idea. So let me just rephrase that. In other words, Herschel was suggesting ways that photography might come to aid the act of drawing. In contrast to Herschel, I will examine some of the ways in which astronomers used drawing as an aid to photography. I'm interested in how the act of drawing assisted photography. And though cooperation exists between the two in Herschel's suggestion, drawing is still the leading partner, a dance that has its own dynamic. Instead, the dynamics I will explore are those where photography is the leading partner. By stressing cooperation in this dance of media, I want to avoid perpetuating hard and fast distinctions between drawing and photography, a separation presumed in so much that has been written about these two activities. I do not deny their important differences, but by now it might be more productive to think about how the two were used together, in joint processes, hand in hand, in order to achieve common scientific ends. My primary focus will be on photographs taken of the nebulae. This is for two reasons. For starters, in the 19th and 20th centuries, one of the most widely regarded triumphs of photography was its application to astronomy. And no other object in astronomy was as challenging for photography than the mysterious nebulae. In fact, when the nebulae were finally photographed, it was said to have been, quote, the only actually modern achievement of photography, end quote. By focusing on the nebulae, therefore, we are in the very heartland of photography's most acclaimed success. So when we find drawings being made within this heartland, we must ask, what gives? Secondly, because unlike other objects in many other sciences where photography and drawing operated together, nebulae could not be simply taken in hand and examined, nor could they be sliced or diced, stained or prepared like microscopic objects. This means that strategies selected for representation were also strategies for a soft intervention. But before we get to the nebula, let me begin with the foundations for all else to follow, namely the stars. Agnes Clerc, a major popularizer of astronomy at the end of the 19th century, proclaimed in her celebration of sidereal photography, that is the photography of the stars, that, quote, the impressions on the sensitive photographic plate are cumulative as well as permanent, end quote. This was said in the context of explaining the progress of stellar photography and its culmination into the Carte du Ciel project, a major international multi-observatory project to photographically chart all the stars of a certain magnitude in the heavens. 10 years after Clerc's declaration, one of the chief astrophotographers of the day, Isaac Roberts, complained that, quote, the records obtained by photography are peculiarly liable to be lost by accidental breakage of the glass negatives. Besides this, there's a certainty that after the lapse of a limited number of years, the gelatin films will become discolored. The images will fade, and the faint stars and the faint nebulosities will entirely disappear from view, end quote. So, for instance, on the 15th of February, 1886, a photograph was taken of a specific region of the sky. Roberts counted 403 star images on the resulting negative. 9 years later, Roberts again counted the number of stars on the same negative and found only 272. 131 stars had simply disappeared off the plate. The solution, thought Roberts, was to find a way to retain the information on these plates by using, in his words, permanent ink. But the problem was not just the disappearance of stars off the plates. For stellar photography to be useful, star images would have to be perfectly round, so as to act as mathematical points and the basis for measurement. But the attainment of circular dots for star images was, as one astronomer put it, quote, the greatest of all difficulties of a practical character, end quote. Assuming one could distinguish tiny, sometimes microscopic stars from the grain and specks found on the same plate, there was still the fact that the star images would often turn out to be asymmetrical, elongated, or just overexposed. These deformed images of stars were considered to be inconsistent with the kinds of precision that was expected, and sometimes were thrown out. Roberts' solution to these problems was to construct a tracing machine, or what he called a stellar pantograver. This was a device that allowed him to accurately transfer stars from the negative glass plate to a copper plate. Transferred were not just stars, but their exact positions and their magnitudes. To do this, the pantograver was equipped with a microscope and a micrometer, that's shown on that side on the left side there. With a microscope and a micrometer with fine lines to bisect the star's center. As the center was determined using the micrometer on the negative, a finely tuned appendage equipped with a steel pin carrying a diamond point, that's on the right side here, would simultaneously also slide over the copper plate. When the arms were exactly positioned in correspondence to both plates, the diamond point was used to engrave a dot of varying sizes corresponding to different apparent magnitudes. The process could be reversed so as to check for errors. So much for stars, at least for the moment. Let us now turn to the nebulae. When it came to photographing them, for a long time the challenge remained this: to capture on one and the same photographic plate the fine gradations of nebulosity along with perfectly round stars. Having both on the same plate would be a huge advantage in measuring what was long regarded to be immeasurable. So you wanted basically the stars, the discrete, and the nebulous fog, the continuous, on both on the same plate. This would go very far in helping the astronomers to then actually measure not only the distances, but also the extent of the nebula itself, the volume of the nebula. But it remained a challenge, because telescopes intended for stellar photography, that's for stars, required long focal lengths, while those used in nebular photography used much shorter focal lengths. So you have to use basically two telescopes. So it was very difficult to get two telescopes in use for one plate. In addition to this, to capture the light of the nebula, dry gelatin plates had to be constantly and uniformly exposed for many hours at a time, sometimes even up to 9 hours of exposure. In contrast, plates used to capture the light of a star were typically exposed for only a few minutes at a time, from 10 to 20 minutes, even seconds. As a result, many stars that did emerge on a negative, as here, for a nebula, were often asymmetrical, elongated, or just overexposed, and thus useless for the purposes of measurement. To begin with, one sometimes encounters such drawings made from photographs. Here we have a drawing made by Roberts of the famous spiral nebula M51. We now call this a galaxy, but back in the 19th century it was still considered a nebula. It was made actually using this photograph of the spiral, previously made also by Roberts. However, as a mere outline drawing, its main purpose is to enable Roberts to compare the rough measurements made of the object with those made by others, such as this, Lord Rosse's famous drawing of the same object from earlier period. But for our purposes, however, a much more interesting case is of the very first photograph of this very object, N51. This is because by the 1880s, the spiral nature of this object was in serious doubt. Lord Rosse had first discovered the spiral character of some nebulae in 1845, using the largest telescope of the 19th century, a reflector with a speculum of 72 inches, that's full 6 feet in diameter. That's the mirror. By the 1880s, some keen observers using much, much smaller telescopes could find and draw the object, but not its spirality. Thus, doubts rose as to the existence of the spiral. The common response to these doubts was simple. One just required a larger telescope to see the spiral's width. The first photograph of this object, M51, was made with an exposure time of 2 hours and 35 minutes on April 11, 1888. Aside from confirming the existence of the spiral structure, this photograph was taken with a small reflector telescope with a mirror of only 10 inches. Compare that to Lord Rosse's, which was 72. As a result of the small aperture used for this photograph, the dimensions of its image on the negative is less than 4 millimeters across. So the actual object that appears on the plate is so tiny, it's 4 millimeters across. And this has something to do with the ratio of the telescope's focal length. Typically, one then enlarged such small photo images by means of photography. So using photography, you could actually enlarge it, magnify it even further. In this case, however, because of the ratio of the image to the particles of the silver that formed it, the plate could not be enlarged without losing relevant details. So if you did apply photography to enlarge this photograph, the silver particles that make it up would actually be overly accentuated, and you would lose all the detail. So what was the solution? It was in conjunction with a microscope that an enlarged drawing was made of the spiral's photo image. And what we have here then is actually an engraving of a drawing of a photograph. Given the current state of the literature on photography in science, one might be tempted to believe that the use of enlarged drawings was done only for the purposes of print and publication. But the article which originally presented this engraving to the world betrays this interpretation, since it is principally composed in relation to at least 4 other handmade drawings previously made of the same object. Each is carefully compared to the other. The task is not to put to shame or reject the drawings, but to use them in relation to the engraving of a drawing of a photograph in order to come to a more complete understanding of the object and the modes of its representation. The engraved drawing of a photograph is thus an instrument here of comparison. Difficulties with enlarging photographs of the nebulae continued well into the 20th century, and the solution to this problem continued to be the use of drawing. Take, for instance, Herbert Curtis's paper on the planetary nebula from 1918. He was a leading observer working at the world's premier institution for astrophotography, which was Lick Observatory in California. The chief purpose of Curtis's paper was to present a variety of forms assumed by planetary nebulae, a class of nebulae of considerable value in understanding the natural history of the heavens. I'll explain that a bit more. When one turns to the plates for this publication, one encounters a total of 78 figures, such as these. However, what at first glance appears to be prints made of photographs, on closer inspection turn out to be, in the majority of cases at least, prints made of drawings. In fact, out of the 78 figures, 61 are drawings, while the remaining 17 are photographs. Now, given that we are in the 20th century already, and at the premier institution for astrophotography in the world, and not to mention the major advances in photographic technologies and the hundreds of successful photographs made by this time, when we find in a major publication drawings and photographs in such close proximity, we must ask what is going on. Planetary nebulae, these are the species here, were especially interesting to astronomers because it was thought that an analysis of their structure might reveal their age and distance, and thus provide a hint as to the age and size of the universe. You have to remember the context here. This is 1918. The cosmology as a science has just taken off. And one of the major problems in cosmology is understanding how big the universe is, what its structure is, how old it is. And these things, from just the determination of the intensity of light here compared to here, or the dark region in the middle versus the very bright one on the sides, provided a structure of light that was crucial for understanding the age and even the distance of these objects. So what these images are useful for, is actually to structurally derive the age of the universe. Now, there are sharply varying contrasts between bright regions and very faint or dark ones, were clear markers to work from, structurally. Now, considering the original size of the image in the negative, any enlargement would jeopardize these crucial structures. That is, if you enlarge these images, you will lose these light structures. But what is more is that in order to bring out an object's varying details on a photographic plate, radically different exposure times were required, ranging from seconds to hours. So if you wanted to get all these different kinds of varying details, these shades of light and dark, on the same photographic plate, you would have to expose that plate to this object using many different kinds of time sequences. So sometimes you would have to expose it for a few seconds, and the same plate then would have to be exposed for a few hours. This was impossible. And therefore, getting all these fine gradations of light of these objects, for these objects, that was so crucial to its structure, was a major challenge. So the catch was, all these different exposure times and exposures, and the corresponding details could not be captured on one and the same glass plate. Therefore, Curtis wrote, "No single photograph of the object will give an adequate representation of all the details of the nebula," end quote. So one photographic plate of an object could not give enough adequate details for the structure. So what was to be done? After many experiments, Curtis adopted what he considered to be, quote, the most satisfactory method, namely the use of composite white crayon drawings done on black paper. This is how Curtis describes the process. For each planetary, a series of negatives of widely different exposure times was secured, so planned as to give a legible photographic record of both the brighter nuclear portions and the fainter peripheral details. The range of exposures was determined by trial, and frequently on the same object from a few seconds to 2 hours. The drawings are composite in that I have endeavored to combine in a single sketch all the details visible in all the negatives of a given object. In many cases, the sketches give a better idea of the sum total of the structural features of a planetary than an enormously enlarged photograph could have done. So what he does is he takes all these photographs, all these different exposure times, all these different plates of the same object. Then he begins to draw them using white chalk on black paper as a composite. So he composites all these drawings onto one image, which is a drawn image. 3 observations are warranted here. First, Curtis's composite drawings are actually used to advance a process begun by photography. The two media complement one another in the pursuit of images suitable to the scientific gaze. Second, although Curtis's drawings are sometimes paired with photographs, like in this case, Michael Lynch's heuristic notion of juxtaposed pairings is not helpful here, because it is premised on insurmountable differences between photography and drawn images, or drawn diagrams. For Lynch, drawings are parasitic on photographs and depend on the latter's surplus of information. Drawings are said to simplify and abstract. In contrast, Curtis's pairings emphasize a process that maintains fluidity between the two media rather than dividing them. And in fact, they show how drawings might even be used to compound complexity rather than just simplify. Finally, in connection to the last point, these drawings contribute to a larger process of research, which does not just end with these drawings. The drawings are then used as instruments of comparison within an experimental procedure, such as this. Using a series of experiments with light reflected at different angles through opaque media in glass containers of different shapes and sizes, Curtis attempted to derive three-dimensional forms that will help to explain the nebular shapes presented in the flat drawings. He is keen, in other words, to escape the bounds of the flat, two-dimensional image and into the three-dimensionality. He is aided in this by the fact that the results of the experiments with glass, light, and fluid are represented using exactly the same media as the drawings of the nebula, white crayon on black paper, facilitating thereby comparison and assessment, judgment, and inference. Here we have the drawings made from those experiments with these glass containers held up to light with opaque media. And what he's trying to do is he's trying to use these experiments to derive morphologically the three-dimensionality of those flat images of the nebula. But crucial to all this is the media used. The black paper with the white crayon helps actually facilitate this process of comparison. Now, let us return back to the 19th century. Isaac Roberts had already appreciated the significance of combining photographs of one object. In writing about two negatives of the nebula in Orion, he proclaimed that the two taken together showed the nebula, quote, more completely and truly than it was ever previously known. In 1895, a year after Roberts' assertion, one of the most extraordinary examples of this principle was published by William Pickering, an astronomer at the Harvard Observatory. Before I conclude then, let me say a few words about this. A print of Pickering's hand-drawn map of the nebula in Orion. There's so much contained in this contour map that much of what I have said up to this point has been meant to prepare us for understanding it. However, given the time, there is no way I can describe all it contains. So permit me to limit myself to some of its most important features. So now what I'm going to do now is overwhelm you okay? Because you won't appreciate the significance of this image without me really overwhelming you. But that's the point here. I'm really stressing the complexity of this fusion. Using 4 different telescopes, Pickering obtained 22 plates of the Orion Nebula. From among the negatives taken with these telescopes, Pickering chose 8 in total. Each of the 8 plates was exposed to the light of the nebula at different times, between 1887 and 1889. In addition to coming from different sites, some of these telescopes were in Peru, some were at Harvard, some were in California. So in addition to coming from different sites, telescopes, and dates, each of these plates is made using standard commercial emulsions. The 8 plates taken from the 22, the original 22, are then divided into 4 and 4, so that half become the basis of the drawing, and the other half the basis of verification. That is, if a feature of the nebula seen on a plate for drawing can also be found on the plate for verification, it is then confirmed for entry onto a separate piece of paper that will form the chart. From out of the 4 plates used for drawing, 1 is chosen as giving the best negative and forms the initial basis of the paper chart. This is plate number B2312. The plate is then further enlarged, and from it a bromide print is made. A bromide print is then taken from the plate, which it's actually usually on paper. So the bromide print is then made from the negative. The print is then attached to a blank piece of white paper behind it. The positions of all the more conspicuous and important stars on the bromide print are then pricked through with a steel pin through to the blank piece of paper behind it. Using these pricked holes, or stars, as standards, the blank piece of paper is then provided with lines to form a scaled grid. Afterwards, stars and all other sorts of other information about the nebula are extracted from all the other plates and are entered by pencil onto the sheet of paper, already prepared with pinholes and a grid. So we have the negative, the glass plate. From that plate, we take a bromide print. Okay, this is the bromide print. Now I'm going to get all my papers confused. And then you get a blank piece of paper. You put it behind the bromide print, and all these fancy and important stars, you take a steel pin and you begin to actually prick holes through it, so that on the blank piece of paper, that you actually have the stars there for you. And then those stars, those holes in that paper, become the fundamental stars that then form the scaled grid that will inform the entry of all the other information to come. Okay, I think I'm on the right page. So it must be noted that on many of the photographic plates, the stars, as in this one, appear slightly elongated rather than perfectly round. As we've seen, this would have been a problem for many interested in measurable photographs. That is, they're not perfectly round. Pickering turned this to his advantage by recognizing that when it came to tiny and faint stars, as consistently deformed marks, they might, as such, be distinguished as true stars, rather than specks or grain inconsistently scattered throughout in such glass plates. So, in other words, if there's a dot or some sort of strange mark, because they're not perfect darts or overexposed marks, if they're consistently the same throughout, you know it's a star. Because otherwise, there would be specks or dirt on the plate. But when transferred to paper, either as pricked holes or as drawn dots, these misshaped stars become dots or holes. The holes, which represent standard foundational stars, are also useful as paper tools that help Pickering to label stars on the reverse side of the blank paper, so as to not to disturb the image with too many marks. But there remain many kinds of marks nonetheless. A series of diverse lines, thin or thick, red or black, solid or perforated, are entered so as to represent different kinds of information about the nebula's complex makeup. This information is extracted from the plates using a variety of techniques, like the use of a magnifying glass or even microscope, and a range of photographic enlargements, only to multiply negatives even further. But of interest are the red lines, or isophotal contour lines. I'm not sure if you can see this, with the red numbers there. These isophotal contour lines are those that measure the light intensity of the object. Which are taken, these lines, these red ones, are actually taken from an entirely different batch of photographic plates that look like this. These were prepared with a thin sheet of brass perforated with very fine holes and exposed using different telescopes to the light of the nebula. The same thing was then done for the same plate exposed to the light of a standard lamp, whose light intensity was already quantified. So on the bottom are actually photographic impressions of a standard lamp. This is a lamp whose light intensity is already pre-quantified. In the middle, you have the nebula of Orion. What you do then is you want them on the same plate so that then you can begin to compare, using your eye, the light intensities between the two. So you know the number of intensity here, and if you could find the same kind of intensity there, you've got the same number. Very clever. Now, the pixelated light of both the photographs of the nebula and the standard lamp are then closely examined so that different intensities of light found throughout the nebula might be quantified. This is a fascinating example of the early use of pixelation, reminiscent of the ways in which today each pixel of a Hubble telescope image is analyzed for a variety of values, including light intensity. Now, considering the amount of marks included on Pickering's map, clutter and chaos was a serious concern. Given this, the pinholes, remember the pinholes, acted as paper tools in another way. If the piece of paper with the star holes poked through it is held up to light, they shine again, as in the heavens, allowing Pickering not to miss any of the fundamental stars now run over by lines, dots, and curves on the paper chart. Far from being novel, pricking holes through stars was an activity already encouraged by some publishers of star charts earlier in the 19th century. A popular one was a set published by James Reynolds of the Strand in 1846. So they encouraged poking through the holes of the stars so that you could have this kind of effect. But however useful these star charts might have been for inspiring popular interest to the heavens, they're not reflective of a scientist's work. So it is instructive to find that Etienne Jules Marais, too, was keen on poking holes. Now, speaking of Marais, you may instantly think of horses arrested in midair. Though horses and nebulae did occasionally overlap, it is Marais' photographs of leaping men that I want to briefly flag in relation to Pickering's hybrid photographic practices. From a series of chronophotographs of Homme Skelette, or skeleton man, Marais was intent on extracting, distilling, and displaying the essentials, the physiological essentials, to the scientific gaze. He did this by producing drawings or geometric sketches from photographs, so that the drawings and not the photographs might operate as the final products and standards for research. And in order to go from photographs to sketches, Marais instructed his assistant, Demini, to poke holes. Quote, "Poke with a needle on the little negative the points of the hip, knee, and ankle." Like the constellation of stars, the holes pricked through knees, hips, and ankles are connected on paper by pencil or ink lines to produce significant forms. As in Marais' case, drawing photographs provided Pickering a means of synthesizing wide-ranging information from many different kinds of media and sources. But these activities also provided Pickering with paper tools that went hand in hand with an elaborate research process, one fundamentally determined by its photographic basis. I haven't written this down here, but I would go as far as to say that, for me, this image is a photographic image. Oops. In conclusion, I will end with 3 points. The first is to draw your attention to the fact that I have resisted the common set of binaries found in works that sharply divide photography and drawing, namely distinctions like concrete abstract objective-subjective mechanical management. I hope to have shown that when both drawing and photography are taken as two collaborative components of an epistemic process, such distinctions are not as helpful as getting a hold on what each is doing in practice in relation to the other. The reintroduction of such distinctions into our story, in other words, would actually work against the proper description and explanation of the cases here presented. What we need is to rethink our categories for understanding this joint hybrid activity. Second, while I have primarily focused on drawings relation to photography, I would like to point out that we've touched on a variety of media under the head of drawing. Media such as paper, pencil, chalk, pen and ink, pins, and even engraving with diamond point. Each of these has its own unique depths, if I may, with photography. One finds, for instance, markings made with stylus directly on photographic plates. Here we have a very famous plate taken of stars. And notice the kind of work that's actually done directly on the photographic plate. If we divide these media theoretically and conceptually within our methodological frameworks, we won't be able to capture such activity, I believe. One finds, for instance, such markings made with stylus directly on photographic plates. Also directly upon the glass plate surface, we find paper pasted on for a variety of purposes like labeling and measurement. Here we have a photograph from the late 19th century of the solar eclipse and of the moon. And notice the kind of paperwork literally actually being pasted on the photographic plate itself. These multimedia inscriptions may occur on both sides of the photographic plate, which highlights the fact that they were treated as three-dimensional objects, thereby encouraging a different treatment than would two-dimensional prints of photographs. It also indicates that far from being mere pretty pictures, these photographs were handled within procedures of observation and scientific research. That is, as a part of the production of scientific knowledge rather than just its presentation. Already, it should be apparent that a photograph might be treated not only as an image, but also as an object and a document. The final point stems from an observation made by a late 19th century astronomer. It is that photography had ultimately changed astronomy's scene of operations. Rather than performing at night at the telescope with pencil and paper and a limited view to the sky, as in this case, astronomers now operated in altered conditions of work in space. These alterations in the scene of operations thus had implications for drawing, making it a different operation than it was when one drew from the heavens directly. In contrast to drawings that were made at the telescope, this meant a new set of performances, postures, instruments, and techniques at the desk. As old as the act of drawing was, it was made new again by photography. Thank you very much.
Now some comments by Professor Dabrowski, followed by some Q&A.
Thank you mostly, Omar, for this fantastic paper. And let me start by saying that it's been an utter privilege to read your recent book, which I recommend to everybody who hasn't taken a look at it, and to also to hear your related lecture today. And it's been a privilege because your project seems to me an exemplary project about the materiality of scientific knowledge, and perhaps exemplary too in the whole material turn that the humanities have taken, where drawing is observation, material representation is knowledge, and the terms are in that sense reversed and come in your understanding almost before their usual order, which would be the reverse one. So nothing is observed or even known really until it is marked, represented, recorded materially, right? And every idea has to be pressed through its material equivalent and cannot exist in any other term. So, and maybe John can say a little bit more about how that represents a larger shift in the history of science in the last 10, 15, 20 years or so, right? And so my remarks and my couple of questions, and again, take them, leave them, pick up wherever you like, are coming more from a historian of art and a historian of visual culture than maybe from the history of science per se. And obviously I like your approach so much because it opens the history of science up to some much more traditional literary studies and art historical procedures. Right? What would an account of Zola's naturalism and objective literature be without us having poured for decades through all the notebooks he assembles for the Wugong Car and so on and so forth. Right? So that you are adopting those more literary procedures and art historical procedures for scientific inquiry. So I applaud that move very much. So my remarks are sort of in two groups, and the first is the provision that when in the history of art or in the history of visual culture, scholars have come along and put their emphasis so firmly on the medium and charted the history of the medium, they have sometimes been reluctant. I'm not saying that you are, but that has often been the effect, to consider referent meaning and content of the mark in a similar manner that the medium has now received the attention. And and that leads me to think a bit, and I think in your book that is a little bit evident too in the way in which your prologue, right, the history of the idea behind the nebula is confined in the prologue that gets a little bit parceled out of the beautiful media history you are telling. Right? But I do want to prompt you a little bit to think about the relationship between mediation and idea, or between mediation and knowledge, and what it is precisely that we glean about the epistemological challenges the nebula pose through this new emphasis and shift in a viewpoint on their mediation. Right? What parts of the knowledge or the ideas about the nebula are particularly affected in not just in our account of the 19th century, but also in the moment when these mediations occurred. So I'd like you to think that relationship or explain it a little bit better for us. Right? What is the place of the idea and the scientific knowledge itself in your account? And the second part of my remarks have to do more with the photography-drawing relationship that you are outlining here today, and I think it comes particularly from a photography history question, because I'm wondering whether how generalizable your account here is, or how specific it is to the couple of decades you are describing. And I'm asking that in part, or to rephrase that, right, is the dance, as you call it, right, or the beautiful hybridity between drawing and photography, is that endemic of a larger relationship between photography and drawing that only the 1840s, 50s, 60s, and 70s could have, that obviously doesn't exist beforehand, right, but that also doesn't continue past that point, because when you speak of photographs, obviously, and their particular evidentiary and objective qualities, that is the 1880s account of the photograph and of the snapshot, right? And before then, in 1839, it's obviously the daguerreotype that gets patented, right? And what we've looked at are calotypes and not exactly photographs of the kind of snapshot, veristic, evidentiary kind that the 1880s make possible. So I'm wondering a bit whether the dichotomy you are collapsing, right, even existed much before 1880, because when a daguerreotype is made and other things are made there, almost drawing is still a big part of the early photograph. Right? Fox Talbot, after all, calls a famous text the pencil of nature when he talks about the photograph. So I'm wondering whether the binary you are dismantling and putting back together isn't already, wasn't even there to be put back together, right? Because the two had not yet been pushed into such opposite camps, right? And the related question to that goes back to a famous couple of things that Foucault said about what he called photogenic paintings, and which is actually how he characterizes the 1860s to 80s. So just listen to this larger characterization of the moment you described, right? The years 1860 to 1880, Foucault wrote, witnessed a new frenzy for images which circulated rapidly between camera and easel, between canvas and plate and paper, sensitized or printed. With all the new powers acquired, there came a new freedom of transposition, displacement and transformation, or resemblance and dissimulation, of reproduction, duplication, trickery, of effect, and so on. So what you're describing seems to me a very historically specific media relationship, and I would like to know whether you agree with that, or what aspects of it you think might be generalizable into a broader media account of drawing and photography for the history of science.
Thank you very much, Andre, for these probing questions. Maybe I could start by just addressing them briefly. Your first question about how does the actual dealing with the intricacies of the media reflect its way back into the ideas and theories. I don't want to speak too much about the book, but in the book, one of the main things I try to highlight, one of the main concepts that I actually hope give birth to, I think, is the idea that through the very acts of drawing on paper, the very tactile sense that that activity entails, and the kind of paper, the kind of resistance the paper gives to the drawing, to the hand, to the nibs, to the pencil, over time gains us what I call familiarity. There's a process of familiarization. It's a gradual, over time process that occurs in the interaction of the astronomer vis-a-vis his notebooks, his paper, his pencils, and the object. And you have to keep, one of the big things in the book that I keep harking on about is that there's no such thing as one instant observation. Observation occurs over many instances of interacting with an object over a long period of time. And so these astronomers that would draw the same object, the very same object, over and over and over and over again for years before they came up with anything that they were comfortable publishing as a standard representation of that object. And it's this going through the process over and over and over again that they gain a familiarity, an intimate familiarity with the object. And it's this that I then try to expand upon and show how it's this that gains us access to the ideas that are connected, the theories that are connected to these things. So I actually try to show in the book that the very act of drawing the spiral, for instance, highlights some very interesting theoretical components to spirality and the nature of spiral nebulae. So the actual drawing of these things, the activity, the real work done with the medium, actually over time and over a long period of process of familiarization of the object, of the kinds of tools to use to represent the object, and so on, help us to gain also a familiarization with what kinds of ideas to connect with them. Or, to put it differently, the process of familiarization gains us access to certain kinds of ideas that are connected to these objects. So it's very much eminent description of what's going on in terms of materials and the epistemic aspects of the materials. It's very much combined. So if I may exaggerate a little bit, the very tactility of it all is where the ideas are. Now, as to the second point, yes. Now, there is a lot of this kind of back and forth happening in many different sciences between different media in a very specific kind of period of time. I partly agree with that. But the challenge for me is to help other historians see that. What I'm doing is I'm actually trying to challenge historians' frameworks of what they see in those periods. And even broader, and even beyond those periods. So it just is so ubiquitous in the literature that there is these sharp distinctions that are continuously made. You find it everywhere, even when you're dealing with these very periods that Foucault speaks about. Historians go back and they just superimpose the same framework on that material. That is what I'm challenging. And so that's the first point. So it's not so much whether or not I'm, describing something that's already just there or not, or that's not a problem at that point. That's not really the challenge for me as much as, challenging the historians who are describing that period. Specifically historians of science and photo historians, and even some historians of art. So there is that aspect here. As for the periodization, I would probably agree but also disagree. I think this material is very much generalizable if we just go and look. And I'm very surprised, I've been doing the research, this material is actually making up the next book, which will be on photography, and I've been going to the archives and I've been just digging up these plates and working with them, and seeing how astronomers were actually engaged with these plates. And one finds things that are translatable throughout. So I would not be surprised, for example, to go to the photographic archives of a botanist or a zoologist or a medical man and find very similar practices. And what I find even more interesting is that these practices continue up to the very middle of the 20th century. So I have cases where I'm actually looking at work being done in the 1930s where people are engaged in these kinds of practices. And this is a very far cry from the 1860s or 1870s, right? And so I think I'm hitting on, it's not so much the period that I'm very sensitive to, but I'm much more sensitive to generalizing the practices, generalizing the techniques, which I do believe they're generalizable to many different kinds of periods, obviously after photography. So that's the idea. I hope I've addressed directly some of the issues. Thank you.
All right, so let's first see if any questions from the many visual studies students are here. Yes.
Yeah. So first of all, thank you very much for the lecture. I really enjoyed it. Second of all, in the process of challenging the framework that many scientists or people studying this in a scientific perspective will bring to the table, in your work, do you ever address why those frameworks are there? Is that part of is that a question that you explore, or is it just challenging it?
Yeah, that's a very good question. Thank you. That's a very tough one because, let me begin by saying this. Just recently, Elizabeth Edwards, who's a very famous photo historian, anthropologist, she just recently came out with this very short essay on just that question, which is very interesting. And she places much of the blame on the treatment of photography as an object of art, as an aesthetic object. And that it's been treated as a surface, as a presentation. It's something to be looked at in frames on the wall, or as prints in a book. And that treatment has played into a huge literature about not only the history of photography, but the role of photography in culture and visual studies and so on and on and on. And so there seems to be a very, beneath these frameworks, there's this assumption that comes from perhaps cultural studies or art critics writing about photography, that photography is to be treated as a presentation, as a surface, as a two-dimensional print or flat image in a frame or something like that, or in an album. And this idea really, it just so happens that this idea informs so much literature and frames so much that by the time the historians of science get to it, we've somehow, I think, adopted these frameworks without fully questioning where they're coming from, and without fully questioning whether or not the treatment of them as aesthetic objects or art objects is sufficient for their treatment as part of a scientific process.
So as a follow-up question, I guess then like, what role would you see, let's say, medium familiarity with the general, I guess, public? Because in the lecture you discussed the relationship with the paper, the pencil, and the astronomer. But in some ways that experience, that tactile experience is like very familiar to almost everyone when they're taking notes. So that manipulation is very much available to everyone.
Yeah.
Whereas the manipulation of photography, while it's very possible as we've seen, and it's definitely not as perhaps when people perceive it, it's not such like a absolute index. But I guess, do you see that playing a role in people's intimacy with photography as a medium?
Okay, good. That's good. I would sort of say that not only historians or scholars, but the public even has a very specific idea about what photography is. You know, they have this idea that photography is something that captures, reality and all these kinds of things that, and they're pixelated or they're digital and they're flat on computer screens and so on. And the idea of manipulating these things is always somehow, even for just regular Joe Blow, is sort of weird. Why are you manipulating it? Like, why are you photoshopping yourself? It just seems wrong. There's something wrong about that, right? There's this idea, and getting to why that we have it as a culture, why we have such a problem with that is a very interesting question. And I would agree, it has a different feel than, say, the touch-up or the manipulation of a drawing. Yeah.
Any other students first? Yeah.
I found myself struck as you were talking about the ways in which these photographic plates seem to almost assume the role of the experimental object in your story. And I wonder if they do that, if they become the referent, if they become the nebula, the extent to which there are different epistemic things from the drawings. Not to reassert a division that you're trying to blur, but that was something that I sort of found myself thinking about. Any thoughts?
It's very interesting. Yeah. You have to realize that, as you most surely do, that scientists were not only experimenting with their epistemic objects or their phenomena, but they were experimenting with how to represent it as well. And photography is a very special case because in many cases that I've shown here, just the emulsion, the kinds of chemicals that you would need to make up the emulsion that would then be the sensitive plate to capture whatever object you want to capture, that itself wasn't standardized either. So each astronomer, each scientist had his own little recipe that he would experiment with, he would play with, he would manipulate. And some would add beer, some would add this, they would have some secret ingredients here. So there was even an experiment with the mode of representation to a very, very sharp degree here, in a way that even drawing perhaps wouldn't, go to that extent. I mean, in drawing you could experiment with the medium. So do I prefer ink or do I prefer pencil for this? But for photography, it's like, do I mix in more sulfur oxide, or do I mix more of this, or mix? And it's literally a chemical experiment. And that's why I began by saying that the nebulae are a very interesting case here, because you can't grab them, and you can't, you can't bite into them, you can't, throw them around, and all you really have to work with here is the kind of the representation you have in your hand, and the way that you go about manipulating the mode of representation. So the very emulsions, the plates you use, the kinds of prints you make from it, will then also affect the way you deal with that nebula. Most certainly. I mean, that came out very clearly with Curtis's case, with these white crayon and black paper drawings. I don't see that as reinforcing any distinctions. Actually, I see that as a part. What I would say then in that case is that the use of paper, the use of drawings, the use of the stylus is just a part of that experiment with photography. That's what I would say. I would put it in these medium or these media into the same status as I would the emulsion. You're playing around with what you have.
So if I could follow up really quickly, I think in your answer, actually, you kind of returned to something that I was trying to get at in terms of, I think my question is, do the photographs become the object under study rather than the nebula out there? As you say, it's not grabbable, right? So do the photographs themselves then become the object that's being evaluated, and the drawings the form of evaluation?
So one of the major distinctions I make, for example, in this book here, is I say there's a distinction to be made between object and phenomenon. And in many cases, the scientist is much more interested in the phenomena than in the object. And what do I mean by that is that sometimes, so for example, you could look at an object through a telescope, like Jupiter or whatever have you. That's nice, that's fun, it's interesting, it could be even entertaining. But for scientific use, for the to actually use that object then within a scientific process that can help the scientists or the scientific community to extract, to distill more and more information, you would have to transform that object into a phenomenon. And phenomena take varying shapes. They could be things that only exist in laboratories. But in the case here, I would say that the phenomena are the drawings or the plates. And that's what they're dealing with. That's what's interesting for them as scientists working with these things that are not objects so much as phenomena.
Yeah, so at the end of your comments, you were talking a bit about how one of the goals was to challenge historians of science. And I wanted to ask you about that with regard to this idea that you had of blurring the manual and the mechanical, and sort of how your view contrasts with this Daston and Galison notion of trained objectivity, or sorry, trained judgment. So it seemed like part of their idea was that there was a point in history about at the time when you're talking about, maybe a little bit later in the early 20th century, where people realized that mechanical objectivity or this use of the camera wasn't enough, and that things like drawing needed to be introduced back in, and expertise from the vantage point of the drawer needed to be introduced back in. So do you see yourself as differing from them? Do you see yourself as kind of drawing out more examples of what they're talking about, or how exactly you orient your project with regard to theirs?
Well, to be honest, I'm reluctant to do so to begin with. It's simply because I'm not. I'm very fond of the book. My work is very much influenced by it. I really think it's a huge achievement. But at the same time, if I just buy into it to begin with, then I'm already constraining myself and the material that I'm dealing with. So to answer your question, if I try to place my own material back into that framework, again, I'm reluctant to do so. What I'm doing is I'm actually undercutting the very engine that drives the whole periodization that they come up with. And one suggestion I'm making here is that one of the components of that engine that goes into, the catalyst that goes into these divisions that they make in periods, and in the notion of objectivity, is precisely this division between mechanical and manual already. So it's already built into their system. That it's that which then is the fountain source, as I say in the paper, of the discontinuities that later emerge at a certain level. So I'm just undercutting that to begin with. So when I do that, then I can't simply just take on what results from it, because I'm undercutting that very point. So that's the first point. So I'm taking the rug from underneath their feet in some ways. But at the same time, they do, even with their periodization, even with these mechanisms in place like these distinctions that go on into producing these epochs for them. Even with that given, then I'm just not very happy with the way that they go about describing, for instance, things like trained judgment, right? Because there, all that ends up happening is that it's the same divisions that inform the way they speak about it. So for them, drawing is still separate. It just it has to be, there's a compromise that's being made, that's being brought in. And when that compromise is made, one explanation for that compromise is that, photography is too concrete. That's another distinction. It's too concrete. There's too much information there. What we need are students who are trained to see the essentials. And drawing